Solve this one here by taking a look at the coefficients, and we can match the coefficients on x, or you can match the coefficients on y, whichever one seems easier. So in this case they both seem relatively easy because they're multiples of each other. So I'm going to eliminate the x variable. So I'm going to take number this equation 1, number this equation 2, and I'm going to take equation 2 and I'm going to double it. So I'm going to do 2 times equation 2. And I'm going to get 4x minus 18y plus 36. And remembering I have to double everything on both sides of the equation. At this point, I can then subtract this. I'm going to subtract all this. And this will eliminate the x variable and leave me with, watch your negatives here, it's going to be minus negative. So positive 15y minus 45 equals 0. I can now solve for y. So I end up with y equals 3. I have to remember that there's another variable to solve for. So I'm going to plug it into one of the two equations. I'll just plug it into equation 2 here. And again, make sure you're keeping track of your equations. Minus 9 times y is equal to 3 plus 18 equals 0. So I end up with 2x minus 27 plus 18 equals 0. I'll combine my like terms, move it to the other side. I get x equals 9. So 2x equals 9, so x equals 9 over 2. So those are my two solutions, or my solution for this linear system. So this is a linear system. This is two straight lines intersecting. So we end up with one solution. In this example here, we're dealing with two quadratics. Now, two quadratics intersecting, and these are quadratics in x. So we could have, two quadratics intersecting like that, and it's possible to have, looks like two solutions here. Okay, we could have 0 solutions because it's possible for this to not intersect. But we're going to see if we can solve this. Now to solve this, if we were to eliminate the variables, we could maybe match the coefficients on x squared and eliminate the x squareds, but we'd be left over still with an x. So what looks like might be easier is if we can eliminate the y variable. So I can add these two or subtract these two equations, and we can more easily eliminate the y variable than we can the x. So I'm going to call that equation 1. Call that equation 2. I'm going to take equation 2 and I'm going to go y equals negative 2x squared plus 1. I'm going to subtract that equation. So I end up with 3x squared minus 2x plus y minus y cancels out. I have 0 minus 2x squared, so that's plus 2x squared. And then minus 1 minus positive 1, so I get minus 1. So here now I've eliminated the y variable. I can solve for my x. This is a quadratic, so I need to solve this as a quadratic. So I get x squared minus 2x, and that becomes plus 1 equals 0. I can solve this by factoring. And so x is equal to 1. If x is equal to 1, I can plug it into my equation. So let's solve for y. I get negative 2x squared. So I'm going to replace that x with a 1. Plus 1. So I end up with negative 2 plus 1. Y equals negative 1. Okay, so that's my solution. It looks like this is just going to intersect in one spot. Okay, so it looks like there is, in this case, this is a double root, so we only have one solution. So if I were to actually graph this, this is an upside down parabola with vertex at 1. This is an upside down, this is a right side up parabola, and it looks like it just touches, that's going to be a point right here, so the parabola, I think, is just going to touch like that. Those two parabolas are going to intersect like that. And we can actually graph this on Desmos to verify this if we want. For this one here, we have two unknowns. We're given a y equals mx plus b, so we're given x and y. So x and y in this can be replaced. We have two unknowns, slope and intercept, the y-intercept. And we could solve this as a system because essentially we have two unknowns, m and b, and we can come up with two equations by plugging in the two x and y coordinates. So my first equation I'm going to generate by just plugging in y is 8, x is 1, plus b. So there's an equation with two variables. I come up with a second relation. Y is 0, x is 5, and there's my second equation with two variables. Here I'm just going to subtract these two equations. So I'm going to take equation 2 and I'm going to subtract it. So 0 equals 5m plus b. Okay, when I subtract this whole thing, I end up with 8. 1m minus 5m is negative 4m. b minus b is 0. Solve for m. I'm going to divide by negative 4. I get my slope is negative 2. And solving for my y-intercept, I can just plug it back into one of the equations. My slope is negative 2 plus b looks like b is equal to 10. And we solved this slightly differently before. If we had 2 points, what we would have normally done is we would have just found the slope between those 2 points. I'm just going to sketch this diagram. 1, 8, 5, 0. Okay, it's going to look like that. There's my slope. It's a rise of 8, a run of 4. So it looks like we have a slope of negative 2. Okay, and from here, that's y equals 8. We know it's going to use a slope of 2 and cross at the y-intercept at 10. So we have our y equals mx plus b. Our m is negative 2. Our y-intercept b is 10. And that confirms what we got using a system of equations.